All right, let's talk about those cool rules. The easier way to find derivatives. I know some of you are mad at me for making you do the long way, but hopefully it'll make you appreciate these rules a little bit more. The first two rules we're going to talk about is one that we call the constant rule, and then a couple that are called the power rule. Now, constant rule is when we take the derivative. Remember, this is a notation for derivative. The derivative of a constant with respect to x. So for example, if our function was f of x equals, 5, right? Well, if you think about that function and the graph of that function, a y equals 5 graph, isn't y equals 5, that function, that graph, a horizontal line? And if you think about any horizontal line, y equals 5, y equals -4, y equals 7,256, they're all just horizontal lines, right? And if derivative means the slope of the line, well, what's the slope of a horizontal line at any point? Well, isn't the slope or the derivative always going to be 0? So anytime we have a function that is just a constant, no variable in it, then we know that its derivative, the slope of its tangent line, is 0, always. It's called the constant rule. Okay, and you might have noticed the pattern for the power rule that we talked about in the intro video. Let's first talk about this one, the derivative of x. Well, if you think about that function, y equals x, it has a y-intercept of 0 and a slope of 1, right? And so if derivative means the slope at any point, well, what's the slope here? And what's the slope here? And what's the slope here? And really, what's the slope at any point along this y equals x graph? Well, the slope is always going to be 1. So the derivative of x is always going to be 1. Now, what if my x had a different exponent on it? 3, 4, 5, you remember 7 at the beginning? If my x had a 7th exponent, x to the 7th, how could I quickly find the derivative using this power rule? Well, you may have noticed that we can take that 7, we can bring that 7 forward, and then we get our new exponent by subtracting 1 from it. So the derivative of x to the 7th is really 7x to the 6th. Way quicker than doing the limit definition, right? Or the derivative of x cubed. I can bring that 3 forward, subtract 1 from the exponent, and I can quickly say that my derivative, the slope of my tangent line at any point, is 3x squared. All without having to do that silly limit definition. So for any x to the nth power, we can bring that exponent forward and find our new exponent by subtracting 1 from the exponent, as long as it looks like this form, where we have x to a certain exponent. Okay, I need you to make sure that you memorize those rules, and not just that you memorize the rules, but you can actually apply those rules to find all different types of derivatives. So if you like to make note cards of these rules, if that helps you remember, or write them down a whole bunch of different times, or write them down on a formula sheet so you can study those periodically. But you have to make sure that you remember these rules so that you can apply them to do all different types of derivatives. These rules will not be given to you on test day. Okay, look at example number 1 with me. If f of x is 9, then what's the derivative of f of x? Well, if f of x is just a number, a constant, then we know that the derivative of any number is 0. All right, look at b. b says, if h of t is pi, then the derivative of h with respect to t is, well, I know pi looks like a variable, but it's not. Isn't pi just a number, 3.14 something, 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 something? So what's the derivative of any number, even if it is a decimal that keeps going? Well, the derivative of any number, any constant, is 0. So be careful. Don't let them trick you by using a pi symbol instead of an actual number that you're used to. All right, what about c? If y equals 2 cubed, then what's the derivative of y? Well, 2 cubed is just 8, isn't it? 2 times 2 times 2. So really, they're asking us to find the derivative of 8. They just wrote it kind of funky with an exponent to try to trick you. But we know the derivative of any number is just 0. So 3 different ways of finding a derivative of a constant, but they might try to trick you by making it look a little bit funky, so be careful. All right, let's do another one. Let's look at example number 2. All different types of problems for example number 2. But here we go. Find the derivative. Well, if you look at A, we have f of x is equal to x to the 6th power. So I have x to a certain exponent, right? And so we know that that looks like power rule. Power rule says that we should be able to bring up the 6 and subtract 1 to find our new exponent. So the derivative of f is 6x to the 5th. All without having to do that limit definition, right? All right, look at B. Now B looks a little bit different. B says g of x is the square root of x. And we don't have a rule that says anything about square roots. So we're a little bit stuck on this one. Unless you can somehow rewrite g of x so that it looks like one of the rules that we do know. Does anybody know how to change that square root? Maybe if you remember from a past algebra class that we can take a radical and we can change it into a rational exponent. So x to the 1/2 is the same thing as the square root of x, where the top number is the exponent that's inside and the bottom number is really my index of my radical. So this would be x to the 1/2. And since I can rewrite it as x to the 1/2, doesn't that look like power rule where I have x to a certain exponent? So the first thing we have to do anytime we see a radical is rewrite it so that it has an exponent instead of a radical. And then we can apply our power rule. We should be able to bring forward the 1/2 and then subtract 1 from the exponent to get my new exponent. So now be careful, we're doing fractions and we need to subtract. So we need to make sure that we have a common denominator. So if I want to subtract 1 from the exponent and I get a common denominator, what I'm really doing is subtracting 2 over 2. Isn't that the same thing as 1, just with a common denominator? So 1/2 minus 2/2 is really negative 1/2. Remember, I brought the 1/2 forward and I subtracted 1 from the exponent. So I get this as my derivative. Now I don't really like this answer because in math, we don't really like negative exponents because they don't mean much. Do you remember how to take a negative exponent and make it positive? Yeah, we drop it down to the denominator. If it's in the numerator and we have a negative exponent, we can make it positive by dropping it down. Now the 1's going to stay on the top, the 2's going to stay on the bottom, but I'm going to bring the x to the 1/2 down so it now has a positive exponent. So my derivative of g is 1 over 2x to the 1/2. I also wanted to point out on this one, do you see how I'm using proper notation? I didn't take the derivative in this orange step. This is still just my original equation, just rewritten, so I'm still going to call it g of x. But then as soon as I take the derivative, then I'm going to call it g prime. So I want you to make sure that you're practicing good notation as you're doing your homework and you're taking your test, okay? All right, let's look at a few more here in example number 2. Let's look at C and D. C and D both also don't look like either one of our rules that we've talked about so far. So just like B, we have to somehow rewrite these problems so that they do look like one of the rules that we've learned. Because none of our rules said anything about the x to the nth power being in the denominator. We only have a rule where the x is in the numerator. So how can we take this 1 over x squared and change it so that it does look like the power rule? Well, just like we did in the last problem, we're going to go backwards though. So instead of having the x squared down in the denominator, can I bring that up to the numerator and make it a negative 2 exponent? If it was x to the negative 2 and I wanted to make it positive, wouldn't I bring it down to the denominator and write it as 1 over x squared? So we can actually use that negative exponent rule to go back and forth and change our original problem into a power rule situation, where we now have the equation y equals x to the negative 2. Now I like it only because this looks like a power rule. And power rule says if I have x to the nth power, I should be able to bring forward that exponent and subtract 1 to get my new exponent. Now be careful. If you're subtracting 1, what's your new exponent? A negative 3, right? Negative 2 minus 1 more is negative 3. I brought the negative 2 forward and I subtracted 1 to get my new exponent. Now that I found the derivative, let's go ahead and simplify my final answer and write my final answer with positive exponents. I like the negative 2. He's okay to have, but I don't like this x to the negative 3. The negative 3 is on the x as its exponent, and we want to make that exponent positive. So leave the negative 2 where he is. It's okay to have a negative coefficient, a negative number in the front. We just don't like to have negative exponents. So let's take that x to the negative 3, drop it down to the denominator so we can make it positive. So our derivative is negative 2 over x cubed. All right, let's look at D. D has another radical. Do you remember when we had a radical in the last problem? We changed it, remember? So we should be able to take our radical and change it into a rational exponent, a fraction exponent. So if it were the fourth root of x cubed, what do you think it would be rewritten as? X to the 3/4, right? Remember where that exponent inside goes as the top number? Okay, I know it's kind of silly, and I don't know even where I got it from, but one of my teachers must have said this expression, and it helps me remember. Top dog goes in the house. So my top dog is the one that's in the house. So that helps me remember which number is going to be in my numerator and which number is going to be in my denominator. So the fourth root of x cubed is really going to be x to the 3/4 because my top dog goes in the house. The 3 goes on top, and then the 4 goes on bottom. Now I have it written as a power rule. I have x to a certain exponent, right? And I should be able to use my power rule to bring forward 3/4 and subtract 1 from the exponent, or subtract 4/4. So I have a common denominator. When I do that, 3/4 minus 4/4 is a negative 1/4. That's my derivative, so I'm using proper notation again, right? Now let's just finalize my answer by making this negative exponent positive. I like the 3 where it is on top. I like the 4 where it is on bottom, but I'm going to take that x to the negative 4th and drop it down to the denominator so it now has a positive exponent. So my derivative is 3 over 4x to the 1/4. Now you could change these back into radicals if you'd like to. I'm okay with that. Or you can leave it like this as long as your exponents are positive. All right, make sure you do a few practice problems with your constant rule and your power rule because we're going to get harder and harder and harder as we go through.